I'm the motivated Mr. Daycock, and today I am going to be teaching you about differentiation using the natural log. So before we start, we're going to need to remember a few rules about how the natural log works. So let's say I have a is equal to e to the power of b. Well, that means the natural log of a is equal to b. And this is just our inverse law. The natural log is the inverse of e to the power of x. Now, that leads on to a couple of other consequences. So, for example, if I have e to the natural log of x, that's always just x. Or if I have the natural log of e to the x, that's also always just x. And this is because they are inverses of each other. And so the natural log and the exponential function cancel out, and you're left with just x. And another consequence of that is that the natural log of e is always 1. Okay, so using that information, we're going to help ourselves understand this a little bit better. So last time I told you that if you had, for example, y is equal to 4 to the power of x, then dy by dx was equal to the natural log of 4 times by 4 to the x. But I never justified that, I never proved it, so I'm going to do that now. What I'm going to do here, I'm going to use one of these here and label the x as 4. So I'm going to write down e to the natural log of x is equal to x, but I'm going to do it with x equals 4. So I get e to the natural log of 4 is equal to 4. And I'm going to replace the 4 here with the 4 here, except I'm going to obviously replace it with this expression instead. And so what I'm going to get is, rather than y equals 4 to the x, I'm going to get y is equal to e to the natural log of 4 all to the power of x. So I've just replaced the 4 with e to the natural log of 4. Then let's start doing some simplification. That gives us that y is going to be equal to e to the power of the natural log of 4 all times by x. And now this is just, we just want to differentiate e to the x with x having a bit of a multiple. And we did that before, so that gives us that dy by dx is equal to the natural log of 4 multiplied by e to the natural log of 4x. And that is no different than before. That is just noticing we've got a multiple in here and remembering that multiples come out when we differentiate. So, and we're not almost done, but we just have to remember that this whole expression here was in fact just exactly the same as 4 to the x. And so this is going to give us dy by dx is equal to the natural log of 4 times by 4 to the x. And we're done. And so that's why that works. That's why I was doing that last time, and that's your justification. So now let's look at a situation where we're actually differentiating the natural log itself. So let's say we have y is equal to the natural log of x. Now, and we want to ask ourselves, what is dy by dx? So this seems a little bit tricky, but it's actually not too bad, because what we want to do is do a little bit of rearranging. So rather than writing y equals the natural log of x, we're going to use the fact that it's the inverse of e to the x and rewrite that as e to the y equals x, or x equals e to the y. And now I'm going to differentiate both sides, but rather than with respect to y, I'm going to differentiate rather than with respect to x, I'm going to differentiate with respect to y. So I'm going to take d by dy of each side. Now, e to the y differentiated with respect to y is just e to the y. That's almost our definition of what e to the y is. And x differentiated with respect to y is dx by dy. But we don't want that, we want dy by dx. But hopefully we can see that it's just the reciprocal. This is the use of the chain rule. Strictly speaking, this isn't justified without some level of proof involved, but for now you can take it as read that the reciprocal of dx by dy is equal to dy by dx. And so I'm going to take the reciprocal of both sides, and I'm going to get dy by dx is equal to 1 over e to the y. Still not quite good enough, because we need to ask ourselves, what is e to the y? Well, actually, e to the y is just x, because we want it all in terms of x. I mean, strictly speaking, dy by dx equals 1 over e to the y is true, but we want it in terms of x, so we get that dy by dx is equal to 1 over x. And that gives us our rule up here. If y equals the natural log of x, then dy by dx is equal to 1 over x. And that's possibly quite surprising. It turns from a logarithmic function into a simple inverse function. And also what's quite interesting here is it actually fills in a rule we had before that was missing. If you remember the power rule for integration, if y equals x to the n, then the integral of y dx is equal to x to the n plus 1, add 1 to the power, and then divide by the new power, divide by n plus 1. But that didn't work if n was equal to negative 1. N could not be equal to negative 1. And that wouldn't. The reason why I can equal negative 1 is because, of course, this would become 0. And that obviously isn't allowed. We can't divide by 0. So we couldn't work. If we were trying to integrate x to negative 1 dx, it couldn't work. We didn't know how to do it. Or in fact, specifically, the integral of 1 over x dx. We didn't know how to do that. Don't get the plus c on the end. But now we do, if we know that natural log of x differentiates to 1 over x, therefore 1 over x integrates to the natural log of x plus c. And that fills in the gap in our power rule for integration. So that's really nice. Okay, also there's one more case. So let's consider this. Let's say I had y equals log base 7 of x. How would I deal with that? Well, I just use my log law that my log change of bases, which tells us that that means that y is equal to the natural log of x divided by the natural log of 7. And that's one of our log laws. And then differentiating that, dy by dx, the natural log of 7 is just a number, so it just becomes 1 over the natural log of 7 times x. And we're done, because we differentiate the natural log and get 1 over x, and we're done. Right, let's go through a few examples of this. So we've got y for a, we've got y equals 4 times the natural log of x, therefore dy by dx, the 4 is just a multiple, so it's just going to be 4 times by 1 over x, which is 4 over x. For b, dy by dx, well, we do have a multiple, but it's inside. So this 4 that is inside is going to come out. So it's going to be 4 times by, and then the derivative of this is 1 over 4x. But that's going to be equal to 4 over 4x, which is actually still just equal to 1 over x. And this shouldn't be, this seems crazy. In fact, what it means is, if I have y equals the natural log of any multiple of x, so let's take, nx, then dy by dx is still always just 1 over x. But that should make sense, because if you remember our log laws, if things are multiplied, then we can add them. So the natural log of nx is equal to the natural log of n plus the natural log of x. But this here is just a number. And when we differentiate a number, we get 0. So in fact, and when we differentiate this, we get 1 over x. So in fact, it does make sense that it always is 1 over x. And lastly, if I have c lots, if c is equal to the natural log, sorry, y equal to the natural log of x to the power of 4, then what we do is we do, again, another one of our log laws first. We bring that 4 out. Y is equal to 4 times by the natural log of x. And then we differentiate it as before, just like in A, y equals 4 over x. And there you go. That's how you differentiate using natural logs. Thank you for watching, and I'll see you in the next video, where we'll discuss the chain rule in a bit more detail.